All right, we're going to continue with 10.7. Continue. Has density 870 kilogram per cubic meter and flow with velocity V equal Z y square x square, where x, y, z are in meter. And V in meter per second. Find the rate of fluid flow outward through the cylinder. X squared plus y squared equal 4. 4, 0, less than equal z, less than equal 1. Okay. Now, find the vector field F. Well, we have the velocity and the density. If you multiply them together, you're going to get a vector field. Density times velocity. Here it is the 870 zy square x square. Okay. Next step is, well, you got to parameterize S there. Now, if you got look up here, what is the best way to parameterize S? Can you parameterize it using the special case? Now this is the cylinder here, and it doesn't look like that you can do this with the special case at all, right? So you got to use the cylindrical coordinate. Okay. Cylindrical coordinate x equal to the radius. Radius is only 2. If you look up here, you see that the radius 2, so it's 2 cosine theta, y 2 sine theta, and z equals z. Yeah. Next step is well, we got to figure out the region D The thing about the cylinder is that you got to be especially careful with the region D. 4. Where does the angle go from? And where does Z go from? And this would be your region D. Okay. Next step is you're gonna have to compute the flux. Flux is double integral S the vector field F dot ds. So I'm gonna do everything right here. Oh, this is the theta Z is the 2 cosine theta 2 sine theta Z or theta. Well, negative 2 sine theta 2 cosine theta 0 or Z 0 0 1 or theta cross or Z. Okay, if you do the cross product, you just gotta be careful, right? Just be careful with the sign here. It's gonna be 2 cosine theta. The second one is gonna be a minus minus. That's gonna be a 2 sine theta. And then the last one is gonna be 0. Okay, next we're gonna do the vector field dot distance here. Do F right here. 870. Z is, well, Z. Y square 4 sine square theta. X square 4 cosine square theta. Dot them up. 870. 2z cosine theta. Plus 8 sine q theta. Okay. Next step is gonna be plug it in here. Parameter S. Two z cosine theta plus 8 sine q theta dA. Okay, well, now, oh man, I was planning to go a little bit down, but 870 The angle theta is 0 to 2 pi. Z is 0 to 1. So we have a 2z cosine theta plus a sine to the power 3 theta dz d theta. Okay. Next step is the work it out. Right. Oh, 870. 0 to 2 pi. Now what do we have? We have a z square cosine theta plus az sine to the power 3 theta 0 1 d theta. One, so it's going to be a cosine theta plus a sine to the power 3 theta 0 to d theta. You have a table, that would be nice because you can look at the table of integration. We're going to save time here. 1 over 3 cosine q okay, so it's going to be a 1 over 3 cosine q theta minus cosine theta. 0 to 2 pi. You can do this by just give you a hint here. Split this out. Sine 3 is the sine theta, sine square theta. So it's going to be a sine theta 1 minus cosine square theta. And then you're going to use the u sub. Then u sub would u equal to cosine theta. 870. Okay, so oh shoot. Sine of 2 pi is going to be 0, right? Plus 8 1 over 3. So cosine of 2 pi is 1 minus cosine of 2 pi is 1. Okay, this time 8. So I'm going to put this in here. 1 over 3. Cosine of 0 is also 1. Cosine of this 1. Okay. Look like it. 870. Okay. Time 8. Oh, shoot. We have the same thing here. So it's going to be 0 in here. And it is just 0. The temperature at the point XYZ in a substance with conductivity. K equals 0.5 is fx y z to be 2x, I mean 2y square plus 2z square. Find the rate of heat flow inward through the cylindrical. Through the cylindrical surface y square plus z square equals 6 for 0 less than x less than equal 4. Step 1, find the vector field F. If you study electricity, you're going to study electricity later on. The vector field F when you have temperature and, I mean, it's heat, not electricity. Yeah, heat, electricity, pretty similar. So you can actually figure out the vector field by using the formula. The vector field is the conductivity multiplied to the partial derivative of f, and then you can do the negative here. This is the formula. Okay, so minus the 0.5 fx fy fz. Okay, so fx is 0, right? Actually, and let me do a fx fy fz minus 0.5 0 for y for z. Yeah, okay. Step 2, same thing, parameterize s. Well, same thing here is the cylinder, so cylindrical coordinate. Here, x is gonna be x. YZ is gonna be root 6 cosine theta. Z is equal to root 6 sine theta for where the angle theta is the same thing, 0 to 2 pi, and then x is between 0 and 4. That is the region D. Step 3, compute flux. Okay. Flux FDS. Okay, so now we're gonna do a FDS right here. Or this you can do a theta x right, because I'm getting used to this one. if we use this one earlier, theta z, then it's going to be theta x right here. Okay, so it's going to be x, and just copy and paste here. Or theta. Pretty much the same. Or theta cross or x. Zero. This one is going to be a root 6 cosine theta. Oh. Huh? Yeah, root 6 x cosine. Yeah, root 6 cosine theta. Yeah. Because minus going to be a and then the other one is going to be a you have to be careful here. Root 6 sine theta. Okay. F is going to be, where's the vector field F here? 0 for y for z. So negative 6.5 for root 6 cosine theta. For root 6 sine theta. Now dot them up. Oh man, almost there. Negative 6.5, 0. Oh, 4 times 6 cosine square. So 24. 24 sine square. Oh, how nice. Cosine square and sine square is gonna cancel out. Oh, negative 6.5 times 24. What is negative 6.5 times 24 here? 156. With a negative. Okay. Normal vector pointing downward. Normal vector pointing down, that means the normal vector, this is the normal vector here, or theta cross or x is negative. Because the flow inward. Okay, everybody okay with this one? Huh? So if you have it a negative, right? So negative and negative is going to give us a positive. So we don't have a negative 6.5 here. We have a, actually this the negative 6.5, but here is 6.5 and 6.5 and 156. Yeah, that look good. Okay, so here parameterize S double integral over the region D 156 dA. And then from here, well, we know the region D 0 to 2 pi 0 to 4 156 D XD theta. Well, this is just a square here. Let me put 156 0 to pi d theta is 0 to 4 dx there. 156 2 pi 4. So multiply them up. 8 times 156 is 1248 pi. The flux of F through S where set up the integral. To compute the flux of F through S where the vector field F is xy plus 2xz x square plus y square xy minus z square. Oh man, it's gonna get crazy if you do the dot product. S is the surface of a solid bounded by the cylinder x square plus y square equal 4 and the plane z equal y minus 2 and z equal to 0. I mean, you're gonna see that there are a total of 3 surfaces. So the flux has to go through 3 surfaces. Three surfaces. So we need 3 surface integral to compute the flux. Everybody okay with this one? You need 3 of them. Right? Flux integral surface 1 f dot ds, that surface 2 f dot ds, surface 3 f dot ds, parameter s1 call it s1, right? How do you parameterize this one? Right? And then here come a different color here. So parameterize S2. And a different color. Parameterize S3. Right. S1 is the circular disk on the XY plane. So if you look at here, circular disk, right? So x equal to 2 cosine theta, y equal to 2. Oh, not 2 though, or cosine theta, sine theta. Z equal to, well, 0, right? Okay, so that is the first one. The angle and the radius 0 less than equal to theta, less than equal to 2 pi, and then the radius is the 0 less than equal to 2. Okay, so get the first one. The second one is the plane that cut through the cylinder. So, well, if you look up here, you can just parameterize it. X equal x, y equal y, z equal y minus 2, right? And then where does the x and the y go from? Right? So for x and y, later on you got to use a different coordinate. But then for if you do y to be well, negative root of 4 minus x squared, root of 4 minus x squared, and x is going from negative 2 to 2, right? So x, okay, the last one is you parameterize the cylinder, right? That is the x equal to 2 cosine theta, y is equal to 2 sine theta, and then z is equal to z. That is the last one. So now where does the angle theta go from? The angle theta is from 0 to 2 pi, and then the z here is no. You think of it, right? You want to do y minus 2 to 0. And once you have these three parameterization, then you can compute the cross product of the two tangent vector, get a normal vector, and then dot with the vector field. It's long though. It's not easy. There is an easier way to do this problem. It will be in the last section.